Derivatives of sine and cosine functions. So the basic cosine and sine functions, if you're taking the derivative of them, the derivative of sine x equals cosine x, and the derivative of cosine x equals negative sine x. So you'll have to memorize those. And when you are taking the derivative of these, you will take the derivative of the trig function and then take the derivative of what's inside, so using the chain rule. And I'm going to give you a number of examples taking the derivative of the trig function and then taking the derivative of what's inside. So here's example 1. It says differentiate y equals sine 2x. So the derivative of the sine function is the cosine function, and then we have to take the derivative of what's inside. Well, the derivative of what's inside is 2x. So the derivative of sine 2x equals cosine 2x times the derivative of what's inside, and the derivative of 2x equals 2. And if I simplify this, what I'm multiplying by 2, I can write it up front. So the derivative equals 2 cosine 2x. Next example says differentiate y equals cosine 2x plus 1 in brackets. So the derivative of cosine equals negative sine, and the derivative of what's inside of 2x plus 1 would be 2. So you can see here the derivative of cosine is negative sine x bracket 2x plus 1 times the derivative of what's inside the brackets, which is times 2. And with it multiplying by 2, I can move that up to the front. And my final answer is negative 2 sine x bracket 2x plus 1 in brackets. Example 3 says the derivative of cosine x cubed. So the derivative of cosine is negative sine x cubed times the derivative of what's inside. So the derivative of the variable, derivative of x cubed, is times 3x squared. And to simplify this, I'm going to, with multiplication, I can bring the 3x squared up to the front. So my final answer would be negative 3x squared sine x cubed. Now take a look at this example, and you'll notice that the exponent is on the variable 3. So it's x cubed. The exponent 3 belongs to that variable x. In this next example, I need to take the derivative of cosine cubed x. And so cosine cubed x can be written as cosine x in brackets all cubed. So notice that this is different from the previous example, and cosine cubed x can be written as cosine x all in brackets cubed. So I want to do this first. I need to rewrite it, and then I'll do the power rule. So the 3 will come out front. 3 times cosine x squared, because I minus 1 from the exponent, times the derivative of what's inside, and the derivative of cosine x is negative sine x. Simplifying this, I'll move that negative sign up to the front with the 3. So negative 3 sine x times cosine x, all in brackets squared. And I can rewrite that portion as well. So my final answer is negative 3 sine x cosine squared x. Example 4 asks me to take the derivative of sine cubed of 4x. So again, I can rewrite this. Sine 4x, all in brackets, cubed. And first I'll need to take the power rule. So the power rule tells me to bring the exponent out front and subtract 1 from the exponent. Take the derivative of what's inside. And then I'll take the derivative of the 4x in the end. So first step is the power rule. So the 3 comes out front. Sine 4x all squared, because I subtract 1 from the exponent. Derivative of sine is cosine, so I get cosine 4x, times the derivative of what's inside, so 4x, the derivative of 4x, equals 4. So just take a closer look at that, because there are a number of steps in there. First the power rule, then I change the trig, take the derivative of trig, and then take the derivative of 4x, which is 4. My final answer, 3 times 4 equals 12. Sine 4x all squared times cosine 4x. In this next example, it says to use implicit differentiation to find dy dx, because I'll have different variables in this equation. I've got the variable x and the variable y, so when I take the derivative of y, that would become dy dx. And notice there at the beginning that I do have the product rule. It's x times sine x, so I'll need to use the product rule there first. So here we go, let's start and see what I've written down. So for the product rule, leave the first term, take the derivative of sine x, which is cosine x, plus the derivative of the first term, so the derivative of x is 1, leave the second term of sine x. So you can see I've put a bracket there in green. That is the product rule of the first part. Plus, now the derivative of cosine is negative sine y dy dx, and the derivative of what's inside, so the derivative of y equals 1. And I need to take the derivative of the right hand side as well, so the derivative of 3 equals 0. So my next step, I'm tidying this up a bit. X cosine x plus sine x, and since I had negative sine y dy dx, I transferred that over to the right hand side of the equation, making it positive. So now I need to solve for, my question is asking me to solve for dy dx. So the opposite of multiply is divide. So in order to isolate dy dx, I need to divide through to both sides of the equation by sine y. So my final answer is x cosine x plus sine x divided by sine y, and that equals dy dx. And nothing on the left-hand side simplifies, so this is my final answer. This is the last example. It says find dy dx for cosine x plus y equals y sine x. So when I take a look at this, I know that I can take the derivative of cosine, because the derivative of cosine is negative sine. And on the right hand side, I can see that I have to take the product rule, because I have y times sine x. And since I'm finding dy dx, I'm going to be using implicit differentiation. I'll also be using the chain rule. So all these things are going through my mind as I'm taking a look at this equation. So my first step, derivative of cosine is negative sine x plus y times the derivative of what's inside the brackets. So the derivative of what's inside, derivative of x is 1 plus dy dx equals, and on the right hand side I need to do the product rule. So the product rule, leave the first term, take the derivative of the second term, so I get y times cosine x plus the derivative of the first term, which is dy dx, times sine x. And you can see on the left-hand side, I have a multiplication there, so I'm going to distribute negative sine x plus y into the brackets on the left-hand side. So negative sine x plus y minus sine x plus y dy dx. So sometimes I refer to it as rainbowing in the negative sine x plus y into the brackets. It's also called distributing. So that's what I did on the left-hand side. And my right-hand side of my equation did not change. Okay, now what I need to do is, since I need to solve for dy dx, I'll have to move the dy dx terms onto one side together. So I think I'm going to select to have the dy dx terms on the right hand side of the equation. So that will shift to the right hand side, changing the sign, and the y cosine x, I'll subtract that from both sides, so it'll become minus on the left hand side. So shifting my terms to get my dy dx terms together on the right hand side. Remember, when you cross over the equal sign, you change the sign. I have to factor out the dy dx on the right hand side. So I'll be left with sine x plus sine bracket x plus y. And the opposite of multiply is divide. So take a look at what I've done. On the right hand side for dy dx, I factored out the dy dx, and then I divided in order to isolate dy dx all by itself. And nothing cancels on the left hand side, so this is my final answer.